Welcome to Super Easy Physics and Mathematics. Today we are looking at the step-by-step solution to IGCSE Chemistry Paper 4 Extended, February-March 2023. And part 1 is going to have question 1 and question 2. And the question 1 is about gas found in clear, clean, dry air and gases formed in polluted air. And then some part of question that have to deal with covalent bonding. Now, the total duration for this paper is 1 hour 50 minutes. You're expected to answer all questions. Total mark is 80 mark. Question 1. This question is about gases found in clean, dry air and gases found in polluted air. Name one gas found in clean air, dry air which contribute to global warming, that is carbon dioxide. State the percentage of nitrogen in dry air, that is percentage carbon, that is at 78%. Then the next one, highest percent, is oxygen, which is the active part of the air, as I use red on it. This is the neutralizing part. Then we have the inactive gases. We have the inert gas that we have. The highest is argon, 0.9. Then we have carbon dioxide, 0.04%. So that is a proportion. So name the substance used to remove sulfur dioxide in flue gas desulfurization. That is calcium oxide. So that is a drying agent. Okay. Nitrogen dioxide, NO2, is formed in a car engine. Formed in car engine. Name the equipment in car exhaust used to remove NO2s formed in car engine. That is, we have the catalytic converters attached to exhaust system of car to convert carbon monoxide and nitrogen dioxide into carbon dioxide and nitrogen respectively. So you have the word catalytic converters. Now, all gases diffuse. Choose from the list of the formulas the gas which diffuse most quickly. Draw a circle around your answer. Now, first of all, you need to understand that Graham's law of gas diffusion says that the rate of diffusion is inversely proportional to the relative molecular mass of the gas. So it is the size of the, so the smaller the molecular mass, the higher the rate of diffusion. And then the heavier the gas, that is the higher the molecular mass, the slower the rate of diffusion. So what you need to do is to calculate, but most students use CO, carbon monoxide, because maybe they feel that the number of atoms is fewer. So because it has only carbon and oxygen atom, which has 2 atoms. So this one have 3 atoms, this one have 5 atoms, this one have 3 atoms, this one also have 3 atoms. So most students wrote carbon monoxide, but they were wrong. It's not number of atoms, it's the molar mass of the compound, so of the gas. So let's calculate the molar mass. You can get this from your periodic table. You can get the molar mass from your idea of the molar mass from your periodic table, which attached to page 12 of the question paper. So molar mass for carbon is 28 gram, 44 gram, 16 gram, 46 gram, and 64 gram. So based on that, the one with the lowest mass is methane. So methane, answer, methane has the lowest relative molecular mass. State one adverse effect of carbon monoxide on human health. Carbon monoxide is highly toxic gas. It combines with the hemoglobin and stop it from carrying oxygen. So even very small amount of carbon monoxide can cause dizziness and headache. Large quantity can cause death. So the major adverse effect is what? It is a toxic gas. Now, carbon dioxide is a reactant in photosynthesis. State two product of photosynthesis. So let's just look at the formula. You have what? The reactant is carbon dioxide plus water. So in the presence of sunlight and chlorophyll, then it produces glucose and oxygen. Now let's just learn how to balance this equation. If you look at glucose, how many carbon here do we have? We have 6 atoms of carbon. Here we have 1, so put 6 molecules. That balance off for numbers of carbon. Then if you look here, how many atoms do we have here of hydrogen? 12. Here we have 2. So divide 12 by 2. That will give 6 molecules. So number of carbon balance, number of hydrogen balance. Now let's balance the number of oxygen. So on the carbon dioxide, 6 multiplied 2, you have 12 atoms of oxygen. Then from water, you have 6 atoms of oxygen. Add to this 12 to give you 18 from the reactant. So here on the product, we have only 2 atoms. So, and here you have 6. So remove 6 from 18, we are left with 12. So divide 12 by 2, that will give you 6 molecules of oxygen. So that is the balance. So what are the two products according to what? Carbon dioxide is a reactant in photosynthesis. So name the two products. You have glucose and oxygen. So that's a direct question. Complete the dot and cross diagram for a molecule of carbon dioxide. Show outer cell electrons only. So you have oxygen atom, carbon atom, and oxygen atom form bond. So hints for you to know the number, the atomic number. So look up your periodic table which attached to page 12 of this question. So that will give you the hint. So let's look at the periodic table. So this is a periodic table. So we are looking at carbon and oxygen. So carbon belongs to group 4 and oxygen to group 6. So that will tell you the valency. So the number of electrons in the outermost shell. Oxygen has 6. Okay. So it belongs to group 6. And then carbon, we have 4 out valency electron to the bonding. So you can look at the carbon group 4, oxygen group 6. Then, so we look at it, the electronic configuration. From the periodic table, we know that the atomic number for carbon is 6, while the atomic number for oxygen is 8. So we have 2 6, then 2. So we have, so we are interested in the outermost shell electron. So now, so that is for carbon, which is the red. So you have 6 outermost shell, so you share it there. See, so it's remaining how many to make a stable configuration? Remaining 4 more electrons. So then if you look at the oxygen, oxygen has 6 in the outermost shell, and this one also has 6. So now you have shared. So if you look at the oxygen, so it's going to share 2 electrons with the carbon, and this oxygen atom will share 2 electrons with this carbon. So eventually carbon is having 1 2 3 4 5 6 7 8 is stable. Then the oxygen 1 2 3 4 5 6 7 8, so it's stable. So you have now, because of this, so it's going to form a double bond. So oxygen form double bond with carbon, oxygen form double bond. So carbon dioxide is a double bond compound, double covalent bond. So that's responsible for the high boiling point compared to other gases with it. All right, so that is bring us to the end of this question. Let's go to the next question. All right, question 2. Lithium, sodium, potassium are group 1 elements. Name the type of bonding in these elements. So you have lithium, sodium, potassium, rubidium, calcium, and francium. So you have the periodic table. This is from the periodic table in group 12. So you have that. Now, name the type of bonding. The type of bonding that take place is metallic bonding. And then because of this metallic bonding, you say sodium reacts with cold water to form hydrogen gas and a solution of strong alkaline. State the test for hydrogen gas. So test for hydrogen gas is bring a lighted split close to the mouth of the unknown gas. If it is hydrogen gas, it's going to produce a squeaky pop sound. So that is the positive result. Now, if you look at this quickly, if we just look at the group 1 element, the group 1 element, the reactivity of the group 1 element, okay, down the group, they react more vigorously with water. So if we look at that, so we have some things to talk about with this group 1 element, the behavior. But let's just answer this question first. So let's see. So it says suggest the pH of a solution of a strong alkaline. So the pH is 14. Now name a substance used to confirm the pH solution of a strong alkaline. Universal indicator. So how do you know? The universal indicator, the color changes based on this variation. So from 0 to 2.5 is red, 3 orange, pH of 3, then light orange, then yellow between 5 and 6.5, then 7 neutral is green, then blue is weak alkaline, then we have navy blue, 9 to, that is weak alkaline, then from 11 to 14 you have strong alkaline. So the strongest can have the pH of 14, and then that will give you the valence, that is the color that it will show. Now write the symbol and equation for the reaction between sodium and cold water. So sodium and cold water, so include the state symbol. Most students ignore that. So we have sodium plus water to give sodium hydroxide plus, and then hydrogen is given up as gas. So this is aqueous, and then we have liquid and then solid. Now this reactivity of group 1 element with water is go violently down the group. So as you move from lithium down, the reactivity becomes more violent. Okay, so that means potassium reacts more violently with water, even explosively with water and fire. So you don't do that experiment personally. Then we just look at other things. The melting point decreases down the group. So this other one have lower melting point, while lithium have the highest melting point. Then the boiling point also decreases down the group. Lithium has the boiling point of about 1331 degrees Celsius, while ribodium have the boiling point of about 668 degrees Celsius. So boiling point decreases. Then reducing agent, so the ability to donate electron. So the reducing agent increases with strength down the group. So down the group, the element, group 1 element, have more tendency to easily release their outermost electron to form ionic compound. So reaction with water increases vigorously. So we'll talk about that. So there are some of the things to just revise with group 1 element. Now, lithium has two naturally occurring type of atom, that is 6 lithium and 7 lithium. State the name given to atom of the same element with different nucleon number, that is isotopes. So they are isotopes. Now, table 2.1, this is the table, show the number of proton, neutron, electron in an atom in ion of lithium. So this one is ionic, this one is neutral. So how do you know the number of proton? Go to your periodic table again, that in the periodic table, so you will see the atomic number. So we'll give you the number of proton. So that is good. So if you look at lithium, so what is the number of proton there? Is 3. So and then if you look at it, with that, the number of proton is 3. So if you look at this, so for lithium, so we've known that, so we have lithium 6 and then the other one is 7. So if you look at this, so this one have 3 proton and this one have 3 proton. Why? Because proton does not take part in formation of ion. It is the electron that is lost or gained. So number of neutron, how do we know that? Subtract this from this, that will give 3. Subtract this from this, that will give 4. So this is a neutral atom. So the number of electron is equal to number of proton. Then if you look at this one, this is an ionic atom. So what is the number of protons? Subtract 3 from 7 will give you 4. But here is a technical part of this question. Now this atom has lost one, the outermost electron has been lost. So 1 electron on the outermost shell has been donated. So there, how many electrons is remaining here? So remain 2 electrons. Now, table 2.2 shows the relative abundance of 2 naturally occurring atoms of lithium. So lithium 6 10% and lithium 7 is 90%. Calculating relative atomic mass of lithium to 1 decimal place. Now, this is the formula. The relative atomic mass of an isotope is the percentage abundance times the mass number, the number of nucleon, so divided by, if it's percentage, you divide by 100%. But if it is ratio, you divide by the total ratio. So if you are using ratio, then here will be the ratio multiplied by the nucleon number and then divide by the total ratio. But here we are dealing with percentage, so we divide by 100. So if you look at this, so I decided to say let this be red and this one be green. And so we have that. So the red multiplied by 6 and then we have green. So multiply by that. So we have it like that. And so add them together. That is 690 divided by 100. So that is 6.9. So that is the relative atomic mass. Potassium oxide, K2O, is an ionic compound. Complete figure 2.1 to show the electronic configuration of the ion in potassium oxide. Show the charges on the ion. So if you look at this, if you look up your periodic table again, so you see that potassium is 19 electrons. So potassium have 19 electrons. So the electronic configuration is 2881. So it has 4 shells. So it's a period 4 elements. So it has 1 electron in the outermost shell. So you have 1, 2. So the third shell, so we have 8, and then the fourth shell have 1. Then, so we have that. So that is for potassium. Then, this is the neutral atom that's not undergone bonding. So, then look at oxygen. Oxygen is group 6 element. So, and it's in period 2. So, it has 2 shells, and it has 6 electrons in the atom, in the valence electron. So let's check that. So you have 1, 2, 3, 4, 5, 6. So after that, so for reaction to take place, so for this one to complete, you need 2 more electrons. And then for this one to attain stability, you can easily lose this electron in the 4th shell. So let's look at potassium. So potassium lose 1 electron, so it becomes positively charged. So because the number of electrons have reduced, then this potassium also donates 1 electron. So this one becomes the number of electrons also reduced and become positively charged. So it has more proton than electron. So this one has 18 electron and then 19 proton. So now the oxygen now have the charge of -2 because it has 10 electron and then it has 8 proton. So while this one has 18 electron and 19 proton. So you have so this is cation, and this anion. So this is the cross and dot diagram you have, and then you put the charges there to get your mark. So you have 16 mark for this question. So let's go to the next question. Question 3. Haber process is used to manufacture ammonia. State the main source of the gas used in Haber process. Nitrogen. Where do you get the nitrogen from? So the nitrogen is gotten from air. So from the atmosphere, can easily get nitrogen. Then this one is gotten from methane in Haber process. Now these two materials react in the presence of iron as a catalyst at the temperature of about 500 degrees to form ammonia. And so then you cool it down because okay, let's just go to the next question and follow. Then the question for the Haber process is shown here. The reaction is reversible. So nitrogen reacts with hydrogen to give you ammonia, and then the reaction to the right is an exothermic reaction. That's why the negative sign. The reaction is reversible. The forward reaction is an exothermic reaction. State what is meant by the symbol delta H. So delta H is the enthalpy change. Okay. Now, if you look at the enthalpy change, so you have the energy and then you have the time of reaction. So here, because it's an exothermic reaction, So the energy of the reactant is higher than the energy of the product. So reactant is on the top, have more energy when the product. So when the reaction takes place, so you have the product, then you have the activation energy, that is the gap between here, the reactant and the peak. So what is the enthalpy change? Enthalpy change is the heat of product, then subtract the heat of reactant from the total heat of product. That gives negative 92. That means the reactants have 92 kilojoule more energy than that of the product. So that is how you get that. Now, state why this value show that the forward reaction is exothermic. Is because it has a negative sign. So the value of delta H is negative. So if for exothermic reaction, the value of delta H is negative, while for endothermic reaction, the value of delta H is positive. Now, state the typical condition and name the catalyst used in Haber process. So I've already mentioned that. The temperature is 450 degrees. Then the pressure is about 20,000 kilopascal or 200 atmosphere. Then the catalyst is iron. So that is for Haber process. So then you know iron is a transition element. Then look at other industrial process and then you look at the catalysts that are used. Now the industrial contact process, which production of sulfuric acid, use vanadium 5 oxide. Then nitric acid, oxidation of ammonia. So we have this, we have platinum, rhodium. Then margarine production, that is hydrogenation of fat. You have nickel. So these are the catalysts, and you see nickel is a transition element. Vanadium is also a transition element. So most of them transition elements are the catalysts that are used for most industrial processes to speed up the rate of chemical reaction, but they don't necessarily take part in the reaction. Complete table 3.1 to show the effect, if any, when the typical condition in the Haber process are changed. Use only the word increase, decrease, or change. Okay, so let's look at this. So if you look at the reaction, you have nitrogen, hydrogen, then you have 2 molecules of ammonia. So if you are going to the right, you have less molecule. Then if you are going backward, you have 4 molecules in the reactant. So 1 molecule of nitrogen react with 3 molecules of hydrogen to produce 2 molecules of ammonia. Now the forward reaction is exothermic. That means the energy of this is less than the energy of this. Now, so what is the effect of temperature increase? If you increase the temperature, the rate of reaction on the forward reaction increase. Now, I want you to understand the Stellian principle that states that if an external constraint, such as change in temperature, pressure, which is what we are looking at, or concentration is imposed on a chemical system in equilibrium, the equilibrium will shift so as to cancel the constraint, to annul it. So now, what is the constraint? That is what? We have temperature increase. Now, temperature increase will encourage what? More of the reactant. So if you look at it, to the forward is what? The reaction increases this. And so if this reaction increases, what is going to happen? Eventually, since it's an exothermic reaction, that means more of this material is going to break down in order to cancel this effect. So what is going to happen? Effect on the concentration of this. is that less of it will be produced. So it's going to decrease. Now let's look at pressure. Now if you decrease pressure, so ordinarily if you decrease pressure, so where is it? We have, where do you have fewer molecules? So if you decrease pressure, so what is going to happen? The forward reaction is going to decrease. And when it decreases, so what is going to happen? Here also, here the quantity of this will decrease, because decrease in pressure will favor the molecule that have more atom, more higher concentration. The reaction will take place here. The one with more molecule that will have higher concentration, so the rate of collision here will increase. So that is why. So in order to annul this decrease, so here is going to be, so if you look at it, then so eventually it's going to decrease this one because less amount of this will be produced. But if you increase the pressure of the system, then more of this will be produced. More of ammonia will be produced under higher pressure. But under lower pressure, ammonia is going to decompose to produce this, dissociate to produce this. Now, no catalyst. Then the forward reaction decreases because the presence of catalyst will favor the production of ammonia, which is the ion, fine ion surface that will absorb this material to increase the rate of reaction to produce more ammonia. So if there is no catalyst, then the reaction, it will not have effect on this, so there is no change. So we've finished this question, so let's go. Explain in terms of collision theory why increasing temperature increase the rate of reaction. Well, this is more of physics than chemistry, but let's see. So if you increase temperature, what is going to happen? The molecule increasing temperature increase rate of reaction. How? Why? Kinetic energy of the particle increases. If the kinetic particle, so then the particle will travel faster and they will collide more faster. So that's why you have higher rate. So frequency of collision between particles increases, and then eventually, then higher percentage of the particle will have greater energy than the activation energy. So that will favor the forward reaction. So the rate of reaction will increase. Ammonia reacts with acid to form ammonium sulfate. State the formula of the acid used. From this word sulfate, you know that it is sulfuric acid. So ammonium, so this equation to form ammonium sulfate. So what is the acid used? So that is the sulfuric acid. State the formula of the acid used, H2SO4. State one use of ammonium sulfate. Ammonium sulfate is used as fertilizer. That is a commercial use. Calculate the percentage composition of mass of nitrogen in ammonium sulfate. So here your periodic table is important again. You look at the molar mass of each of the elements. So the molar mass of ammonium sulfate, so let's do that. How many atoms of nitrogen? 2. So 2 times the molar mass, 14, give you 28. How many atoms of hydrogen? 8. So 8 times 1, molar mass of hydrogen is 1. Then sulfur is 1, that is 32, molar mass. Oxygen, 4 atoms. So 4 times 16, that will give you 64. Add everything is 132. Now, what is the mass of nitrogen? So to calculate mass of nitrogen is 2 atoms of nitrogen, that is 28 grams. So what is the percentage composition? That will be mass of nitrogen over the total mass of the compound. So expressed in percentage. So that will give you 21.21. So to one decimal place, that is 21.1%. So with this, we have come to the end of this question. I know that you are a brilliant student who want to succeed. More tutorials solving past exam questions to assist you will be uploaded. So please subscribe to keep up to date. Please kindly like, comment on the video, and feel free to ask any question. I'll make room to answer you. Thank you for watching. Please go to part 2 to continue question 4 and 5 to finish up the review of this chemistry extended paper 4.